Okay, folks, my name is John White, and I'm the developer of the EMS HVAC load calculator. In this video, I'm going to show you how to perform a load calculation using our software. To access our software, go to hvacloadcalculator.com/home. And be sure you put the home on there, otherwise you'll go off to another site and get lost. So go ahead, just put the home on there, and so you end up on this page right here. Once you have purchased the program, you will have created a username and password. So you click on the login button, and here you are at your login page. We're going to be doing a calculation on a residence, so we're going to do a residential, and I want you to put in your username and your password, click login, and hopefully it'll bring you to, there you go, it's bringing you to the load calculation page. I'm getting a drink of coffee here a second. Getting kind of old and lazy on this thing. Okay, so here we are. The first thing you want to do is fill in your client's information. In this case, do that. This house that we're working on is going to be in the Raleigh, North Carolina area. You can use this calculator for anywhere, but for purposes of giving you a demonstration, we're going to use Raleigh, so RALEIGHNC. I think I spelled that right. And we'll give the old television phone with an email address and the date for today right there. All right. So now we're going to get into the meat of this calculation. I think before we start this thing, let's talk about all the math you need to know. A lot of people are under the impression that you've got to be a student of Archimedes to do a load calculation. Well, I'm here to show you something or tell you something. You only need to know two formulas. Two. And let me show them to you right now. There it is. You need to know how to calculate area, and you need to know how to calculate volume. Area is the length times the width. If the house is 34 feet by 65 feet, the area is 34. Let me get you out of it. Times 65 is 2,210 square feet. To get the volume of this house, you need to know the length times the width times the height, which is 34 feet times 65 feet times the 8-foot high, which comes to 17,680 cubic feet. Or you could just take the area, because the length times the width of the area. You take the area times the height, which is 2210 times 8, and you still come up with 17,680 cubic feet. Just remember, area is length times width, volume is length times width times height. That's all the math you got to know to do a load calculation. Now, you might have to do it a number of times to where it becomes ad nauseam, but nevertheless, that's the only math you need to know. So let's go ahead and go back to my calculator here. And the first thing it's asking you is, what are your design temperature conditions? Inside the house, we want to try to maintain a temperature in the wintertime of 70 degrees. Now that can be changed. If you want to keep the house at 65 degrees, and that's part of your design criteria, put 65 in there. But 70 is generally where you want to be. And in the summertime, you want to be able to maintain 75 degrees inside the house. Now your outdoor design temperature, that's how in the wintertime, how cold is it likely to get? Not the coldest that's ever been on record, just how cold it's likely to get 99% of the time. Same thing with the summer. How cold or hot is it likely to get 99% of the time? Again, it's not the hottest it's ever been on record. Now, where do you get that information? Go back to my website and click on degree days and outdoor design temperatures. It'll give you a chart. You come on down here to find your state. In this case, it's North Carolina, if we can find it. Raleigh has a wintertime outdoor temperature, design temperature of 20 degrees, and a summertime outdoor design temperature of 92 degrees. I also want to point out that Raleigh is located at 35 degrees latitude. Later in this calculation, you're going to need to know that, so just kind of remember that. If you can. If you can't, we'll come back and get it later. So let's go back to our calculation. There it is. Okay, so our outdoor design temperature is 20 degrees. For the summertime, it's 92 degrees. And I'll give you a temperature difference of 50 degrees in the wintertime and 17 degrees in summertime. Over here, it's asking you what direction is the house facing. Well, it's facing south. And then it's asking you what is the total square footage of the house. 2,256 square feet is the square footage of the house. By the way, here's your house right here. We got this section right here is 32 feet by 56 feet, and that's 1,792 square feet. This section up here is 18 square feet times 18 square feet, which is 324 square feet. And over here, this section is 14 square feet, I'm sorry, 14 feet by 10 feet. That's 140 square feet. So we add all three of these together and we come up with 2,256 square feet. Total square footage. I hope I didn't lose you there. Anyway, let's go back to our calculation again. I'm going to move on down here. All right, that was the whole book. That's all the math you need for tab number 1, by the way. We got to do the load calculation. I don't want all these things to scare you here. The only thing we will have to do is step 1, 2, and 3. So we almost took care of step 1. Got all the math out of the way. That's the tough stuff. How humid is it in Raleigh, North Carolina? It's moderately humid. How tight's the structure? Well, this house was built in the 1950s. The construction is pretty decent on it. It's a relatively tight house, but not very well insulated, so we're going to say it's an average house over 1,500 square feet. And that'll give you your air changes per hour due to infiltration. All right, now we're talking about fireplace. The house has got one fireplace, and it's of average tightness. And the number of occupants. Generally, it's the number of bedrooms plus 1. We've got a 3-bedroom house. Add 1 to it, so there's four occupants in the house. Okay, we took care of step 1. Let's go to step 2, which is the next step right here. Now we're going to get into probably the toughest part of the whole calculation. And it ain't that bad, just tough. I'm going to skip this overhang characteristic area right here. That's all this stuff. We'll come back to it in a few minutes. Okay. First thing I'm going to go down here. It says solar gain through glass. This is how many BTUs is coming through your glass due to the effects of the sun's radiation and just the temperature difference between the inside and the outside. All right. First question it's asking you right here is. Let me back up a minute. If this was a new house and you had new windows in it, you would more than likely have the specification of your window, or specs on your window, and it'll give you the U value and the SHGC, which stands for solar heat gain coefficient. All right, but we don't have that here. because this is a house built back in the 1950s. They didn't have any of that information back then. Okay, so we're not going to check that because we don't have the information. So coming down here, it wants to know what's the area of all the windows facing north or shaded. So let's go back to my picture again. And here we are. This is north. So I got 12 square feet plus 9 square feet is 21 square feet plus 12 square feet is 33 square feet plus 10 square feet is 43, another 10 is 53, and 12 square feet over here is 65 square feet. Back to my calculation. Facing north, I have 65 square feet. Now I want you to notice it says north or shaded. Well, all your windows facing north will always be shaded, and anything else is underneath a porch or carport or something like that would be a shaded window. So let's go back to my picture again. You'll notice this has got a carport right here. It's facing east. There's a window here that's shaded. It's 12 square feet. So we're going to have to go back to my calculator and add 12 square feet to the north because it's shaded. So that's 77 square feet of total area that is north and shaded, of course. So we have 77. The next question is how many square feet of windows do we have facing south? Go back to my picture again. I got 12 square feet plus 12 is 24 plus 24 more square feet is a total of 48 square feet. So back to my calculation. 48 square feet. Next is facing east. Go back to my picture. East, I got 10 square feet plus 10 square feet is 20 square feet. And then down here I got 12 square feet. But remember, we already put that 12 square feet facing north. So we're only going to put in this window and this window, which is 20 square feet facing east. Back to my calculation. East, 20 square feet. And finally, west. Back to my picture again. Facing west, I've got 12 square feet plus 12 square feet plus 10 square feet. So 12 and 12 is 24. Another 10 is 34 square feet of glass is facing west. Back to my calculation again. 34 square feet. Now we're going to say the type of glass. This house has storm windows on it, so that's double glass. Double glass. Okay, folks, all of my windows are double glass. And if you'll notice, it's asking here, does it have reflective coating on it? The house windows do not have any reflective coating on it, and there are no skylights, so that's zero. This is telling me that my total heat gain through glass in the house is 7,818 BTUs. Now, as I promised you, I'd come back up here and get this in a few minutes. Now, I want you to notice something. I'm going to try something here. If I can get this thing to work there. Get a draw pencil. Alright. Imagine the sun being up here, right there. It's shining on the window like this. That overhang is shading some of the window. This part of the window is shaded. This part of the window down here is unshaded. Now, what this whole section here does is determines how many square feet of the window is shaded, how many square feet of the window is unshaded. So we've got to answer the questions that it's asking in these little boxes right here. Okay, on the east and the west side of this house, we have no overhang, so we just leave that as 0. If the house had no overhang at all, we wouldn't even have to do this calculation at all. Or if it was like a 6-inch, a little 6-inch overhang, and it's not doing any good at all, don't even put anything in there. Don't worry about it. But in this case, this house on the let's go back to let me go back. Get me out of the way. Put that here. All right, I'm going. I gotta do so. I gotta get something out of the way here. Clear that picture right there. There you go. Okay. Now we got that out of there. All right. Okay, so let me go back to my picture here. First question is asked you, what's the distance of the overhang from the top of the window, which is A, from the top of the window to the overhang. In this case, it's 6 inches, and we've got to enter it as a decimally feet. 6 inches is a half a foot, which is 0.5. It's facing south. Let's go back to my picture again. I got an overhang here. Oops, not that. Got the overhang down here at the bottom. So that's all facing south. So back to my little calculation. A, this distance is 0.5, a half a foot. Next question down here is what's the length? How far does it stick out? That's B. That's 18 inches, which is 1.5 feet. 1.5 feet. All right. Now I don't have to put anything over here because the window's all shaded anyways. Right now, just leave it. If it was facing northeast or northwest, I would put that in there. All right, the third question is what's the total linear feet across the top of the windows located below the overhang? You see this picture up here. It's asking you what is this length? This total length from here to here and plus from here to here plus from here to here. In this case, it's 3 feet plus 5 feet is 8 feet plus 3 more feet would be 11 feet will be the total length under the overhang. We'll go back to my picture. I've got 3 feet plus 3 feet is 6 feet. Another 6 feet is 12 feet. Back to my little calculation. I now got 12 linear feet of going across the top of all the windows. And now that I put that in there, it's reflected in our calculation here. You remember it was 7,800 BTUs of solar gain. Now because of some of that shade from that overhang, it's now down to 7,100 BTUs. So the overhang can make a big difference on a load calculation. So be sure you use it if there's enough overhang to make a difference. Now we're going to come on down. We're still on step 2. I told you that was the most difficult part of the whole program. It's not bad. It's just tedious. Okay. All right. Where are my ducts located? They're located underneath the in a crawl space under the house. Located crawl space under the house. How much insulation do we have on? Well, here's your question. Are we going to put in a new duct system, or are we just going to make a change out and leave the ducts as they are? Let's say it's a change out and we're lazy. We're just going to leave. We're not going to replace the ductwork. Well, it's pretty old ductwork, so it's got about a 1 inch of insulation on the ductwork, which is an R2. The duct's never been sealed, so we're going to put it unsealed. And it's asking you for the area of the attic or floor where the duct is located. Well, they're underneath the house and they're scattered all throughout the floor area. So the area of the floor is 2,256 square feet. Remember, right? Now, if the ducts were located up in the attic, you would do the same thing here. That'd be 2,256. But then they want to know how hot is it up in that attic. What's the temperature in the attic? I would have probably guessed 120. It's a guess, really. So, but nevertheless, you don't have to put anything. It's not going to affect the calculation. Okay, that's step 2. Now, step 2, like I say, is the toughest part of the whole calculation because you got to deal with all those windows. All right, let's go to step 3. This is your third step. And it's going to ask you what's the area of the walls. I'm going to go back to my picture a second. That's the gross wall area. That includes windows, doors, and everything. So back to my picture. Okay. To get the wall area, the gross wall area, you start at one corner of the house and you measure all the way down around the perimeter of the house and back. And that happens to come out to 240 feet. We got that while we were out there measuring the house. So I'm going to go back to my calculator here. And let me find my calculator. So the area equals the length times the width. Well, 240 linear feet in one direction, and 8 feet going up. So it's 240 times 8 is 1,920 square feet of wall area. All right, the calculator has already told you got 179 square feet of glass. Doors, go back to my picture a second. I got 1, 2, 3 doors, and they're all 21 square feet. So that's a total of 63 square feet of glass area, a door area rather. So put in 63 square feet. The ceiling is 2,256 square feet. Floor is over a crawl space, 2,256 square feet. If it was like a beach house, you'd still put 2,256 here. However, if the house was built on a slab, and remember this is the only time you deviate from area. Instead, you put in the linear feet around the house, which, if you remember, was 240 feet. A slab on grade, and I said on grade, not below grade like a basement, but a slab on grade loses its heat from the edge of the slab. So you put the total length of the edge of the slab, which is 240 linear feet in here. Okay, the next question they're asking down here is what's the cubic feet of the house. Now that's where we got to get volume. Remember, that was the volume equals the area times the average ceiling height. The area is 2256 times 8 feet high comes to 18,048 cubic feet. 848 comes to 18,048. All right. If you'll notice, I did not put any commas in that number. Don't put any commas in any of these numbers. It'll give you a false program, a false answer if you do. Okay, we're almost through with this thing. All we got to do now is enter. Sometimes you'll already have 1,200 entered in this cell right here. If it's not there, put in appliances for the heating. The heat that the appliances give off is about 1,200 BTU, so that's a standard number. Just go ahead and use it for almost all your calculations. The only time you deviate is if the homeowner was maybe in the catering business and had 4 ovens and a few grills and all that going in the house. So 1,200 will work for the most part for almost every house. Okay, so that's it. We have done the load calculation, folks. So down here, we're talking. Let me back up. We haven't done a load calculation yet. I got to go back and select my insulation values. Okay, my glass is double. My doors were storm doors. My ceiling's got R11 in them, 3.5 inches of insulation. My walls have no insulation. The floor has no insulation. I'm in Grandma's house. It's an older house. Okay. Now we'll go down here. And Total heating load is 84,324 BTUs. So we'd probably end up with about 100,000 BTU furnace in there to cover that 84,000 BTUs. The air conditioning load is going to be a total of 38,029 BTUs. Of that, 33,000 of it's sensible, and 4,400 BTUs is latent. It's asking you to put in 3.61 tons of air conditioning. That's you might put a 3.5 in there, or a 4 ton. You can talk it over to the owner, say, "Oh, you know, you're pretty close to a 3.5 ton unit." But if the homeowner's is really worried about staying cool, let him make that decision. If it was my house, I'd put in a 3.5 ton. All right. One other thing this calculator does is that in the new super insulated houses, they're requiring outdoor air to be introduced into the house. In this case, you would have to put in 52.5 CFM of outdoor air. Well, folks, it looks like that's the end of this demonstration. I hope you found it helpful. And a load calculation is not that difficult to do. You know, as a matter of fact, once you've done 2 or 3 of them, it wouldn't take you more than 15 minutes to do the average load calculation. I want to go back to my my website here if I can find it. All right. You'll notice up here it's got you calculate. It says load calc survey worksheet. You can click on that and print this out and carry it out to the house. And this is the information. You can draw your picture here, and over here is the information it's going to be asking you. This is what you've got to collect to bring it back to the office if you want to sit there and do a load calculation. And all your information's on this sheet. You can even use this sheet if it was right soft or somebody else's software. And that's it, folks. Hope you enjoyed it. Let me see if I can get out of here somehow.